Good afternoon, folks. This time around, I'll take you through, I think, about two or three problems centered around motion. Here, we are going to be interested in either vertical or horizontal motion. We'll be applying equations of motion here and there. And if we get a chance, we might extend to momentum. So, all right, let's have a look at this problem. A particle P is projected vertically upwards from horizontal ground with speed 15 meters per second. So, find the speed of P when it is 10 meters above the ground. So let me pick my pen. We are saying this object has been projected with an initial speed of 15 meters per second. And what we know is if the object is going upwards, then we will take our acceleration due to gravity as negative 10. So that's meters per second squared. So we are given also S, which is 10 meters above the ground. Our interest is to find V, the final speed. So from our Subart equations, we have V, U, S, and T. I think the best equation to use here will be V squared equal to U squared plus 2AS. And when we do our substitution, actually we are looking for V. So V squared equal to, initially it was 15 squared plus 2 multiplied by negative 10 multiplied by positive 10. Sorry about that. Let me return. Okay. So we are saying this has to be, sorry, it has to be um, actually positive 10, right, instead of this. Then when we simplify, it's going to be v squared equal to 225 minus, when we simplify 2 multiplied by negative 10 multiplied by 10 gives us negative 200. And the simplification gives us our v squared equal to actually 25. So v will be equal to root of 25. Therefore, our v is actually 5 meters per second. So that's how we will resolve the first part. Let's have a look at the incoming part, which is B. And at the same instance, that P is projected, a second particle P is dropped from a height of 18 meters above the ground in the same vertical line as P. So find the height above the ground at which the two particles collide. So I've got a scenario where one particle has been projected with an initial speed 15, and we know that it's going with a negative acceleration, but we don't know from the ground it's going to reach a certain height h as when it collides with another particle q. So this is particle P we are looking at. Let's see. Particle P is the one that we are looking at right now. So this is particle P, but at the same time we are told somewhere above there is another particle, particle Q, which is dropped. But what we know is when it is dropped, initially speed was 0, and its acceleration due to gravity, because it's going in the opposite direction, is going to be 10. But one thing that we know is when these two objects collide, the same value of t will exist for either objects. And what we know is since from the top to the bottom, we are told is 18 meters. So what it implies is if a particle P moves h meters up, then it implies that Q is going to travel 18 minus h, so that when we add the two, the result is always 18 meters. Now, with what we have there, what can we do? I think we might be interested in finding the value of t when these two particles collide. Once we have t, it means we can easily come up with the height, because we'll be having initial speed, acceleration, and time, so we can easily find the height. So let's try and see how best we can find t. I think this time around we're going to make use of simultaneous equations. Because we've got two unknowns, that's t and h, but our interest is to find t. So let's see. When I've got s, u, g, and t, I think the best equation to use for this scenario is going to be s equal to ut plus half a t squared. And it has to work for both. So when I do the substitution for particle q here, it's going to be the s there is going to be 18 minus h equal to, because initially it was at rest. I mean, it was dropped, so it means this whole part becomes 0. Then we have got a half multiplied by a. The acceleration we know is 10, but t is unknown, so it will remain t squared like that. Now, if I simplify this equation, it gives me 18 minus h being equal to 5t squared. Let me try for particle p. So this was for particle q. Particle p is going to be, because it's going h upwards, so it's going to be h equal to half, well, it's ut, but initially its speed is 15, so it's going to be 15t, but the acceleration is negative, so it's minus half multiplied by 10 multiplied by t squared, because t is unknown. And when we simplify for h, it's going to be h equal to 15t minus 5t squared when I simplify it. So my interest this time around is to connect these two, because it's going to be simultaneous equations where I'm interested in eliminating one of the unknowns. I'm going to start by eliminating h because I want to know the time. So in the process was actually these two equations rather, because I simplified. These are the ones we are dealing with. So I can easily write this one below to say it's 18 minus h equal to 5t squared. And when I do so, I'm just going to sum in line. And when I sum, these two are going to cancel. So I'll remain with 18 being equal to, and also these two will cancel. So that's 15t. And as I proceed with the calculation, it will end up being t equal to 18 divided by 15 seconds. So I've got my time. And with my time, what can I do? I think it can help me to find h. How do I find h? I'm going to take advantage of this equation because it's the one which gives me the height above the ground. So I'm going to rewrite it as h equal to 15 multiplied by, oh, our time is 18 over 15 minus half multiplied by 10 multiplied by 18 over 15, all this squared. And when I simplify, these are going to cancel. I have 18 minus, let me pick my calculator and try and resolve 18 over 15 squared. But remember, half times 10 here gives us a 5. So whatever answer I'll get, I'll multiply it by 5. So let me pick my calculator and say 18. Then I bring the fraction over 15. Then I say equal. This is what I get. So what if I square this? It gives me that fraction, which I want to multiply by 5. And it will give me 7 and 1 over 2. Let me change it to decimal form. I think it gives me 7.2. 7.2. So I can come here and say 7.2. Therefore, the height that I'm interested in, let me try and simplify. It's going to be, that's my h finally. Let me bring my calculator again. I don't want to make a mistake. 18 minus 7.2, that will take me to 10.8. So it means the height when these two, or is 10.2, 10, sorry, 10.2 meters above the ground. That's the height where these two particles will actually collide. So let's continue and check if there is something. Well, it's now a new problem. We can pause for now. I'll proceed with the next problem just after a while. Thank you.